A fisherman has caught a very large 5-kilo fish from a dock that is 2 meters above the water. He is using a lightweight fishing line that will break under a tension of 60 newtons or more. He is eager to get the fish to the dock in the shortest possible time. If the fish is at rest at the water surface, what is the least amount of time in which the fisherman can raise the fish to the dock without losing it? So I guess our first step for me is to try and understand what's happening in a diagram. So we have a fisherman who's on a dock 2 meters above the surface of the water, and there's a fish here that weighs 5 kilograms. The fisherman has caught this fish and wants to get it to the dock in the least possible time. So we know the weight of the fish, that is weight equals mass times acceleration due to gravity, is a vector going downward, and the maximum tension on the fishing line, tension is always being pulled, so in this case it's being pulled upwards towards the fisherman on the dock. T, the maximum tension, is given to us as 60 newtons. Our weight we can calculate as 5 kilos times the acceleration due to gravity, which is 9.8, which is equal to 49 newtons. So that differential between the tension going upward and the weight of the fish going downward is 60 newtons minus 49 newtons, which is 11 newtons. So that is the force with which he will take the fish from rest on the water surface to the dock. That is the force with which he can do it without the fishing line breaking. So we know force equals to mass times acceleration. So we know our force and we know our mass. So we can find where acceleration is. We know our force is 11 newtons, which is the force maximum which he can use to bring the fish to the dock. And we know our mass as 5 kilograms. What is our acceleration? So calculator, 11 divided by 5. So bringing 5 to this side of the equation, we find our acceleration is 2.2 meters per second square. So now we know acceleration, we can find what our time is by using the position formula. So the position formula is position final equals position initial plus velocity initial times delta t plus half acceleration times change in time, the whole square. So our position final, which is 2 meters, our position initial is 0. Our initial velocity, the fish was at rest, which is given to us in the question, is 0. So this value will be equal to 0. Plus half, our acceleration we found is 2.2 meters per second square. And what is our delta time? So calculating for this, we end up with our delta time, the whole square, equals to 2 into 2 divided by 2.2. So we can find our delta t as the square root of this value, which is 1.818. Our delta t we find as 1.3 seconds. This is the minimum time with which the fisherman can hook this fish and bring it, once the fish is already hooked, to bring it to the dock surface. Given the tension of the rope and the weight of the fish, we found the differential, the maximum force maximum which he can use, and through that we found our acceleration, and then we found our time using the position formula here.